Okay, so welcome to this talk. So in the previous talk, we heard about how to do these upgrades, skip a release and do an upgrade, and everything will work. But in this case, we'll hear what to do when things didn't work, and basically how to recover from failures. So we have Geoff here. Very welcome, and let's see how we can recover our OpenStack deployment when things fail. Welcome.
Okay, thank you. Okay, good afternoon all. Geoff Higginbottom, work for Rackspace. I'm a cloud architect there. My role is basically designing Rackspace private cloud solutions. But I'm not here to talk about that. I'm here to talk about what I've done is my little test environment. So a very brief intro about myself. Ex-Royal Naval engineer, did 10 years in the Navy. Since then, I've had 18 years working in the IT industry. Yeah, I'm getting old. I feel it as well. Prior to this role, I've built a successful IT services company, which I've sold. I've also started a second cloud consulting company, which is still going strong. But I joined Rackspace about a year ago when I moved over to the OpenStack arena. In my previous role, I've built and designed many different public and private cloud solutions. So I've been around the cloud world for about the last five or 6 years or so. What I do for fun? So basically sailing, scuba diving, photography, DIY, theatre building, or theatre prop building, sorry, motorcycling, looking after my daughter, and occasionally I do some work as well when I get the time. But that's far more fun than work. So why have I done this? So my role in Rackspace is to help our customers adopt our private cloud solutions. And as part of that role, I have to do demos of the environments, demos of OpenStack, and also actually look at new technologies, new features within OpenStack as they're coming online. So I need to build test environments and be able to ensure that they're going to come up online when I need them, and they're going to function. I need to know that before I walk into a demo, it's working. There's nothing more embarrassing than walking into a customer demo, showing our amazing solution, and it not working. Now, when I use our real sort of demo environments, they're fully monitored by our support teams, not a problem. But if I'm at a conference like this where I'm showing OpenStack and I'm sort of self-contained, I want to know that it's actually working. I've not got that backup of the full-time monitoring. So I wanted to ensure that the environment is going to work. But also, I'm quite new to OpenStack. I've been in this arena for about a year, so I wanted to enhance my knowledge on OpenStack and how you build it and configure it and monitor it, etc. So it's I said about this project about 6 months ago on the back of actually the Austin Summit, where I saw a colleague give a workshop on using this type of configuration, but he didn't actually talk through how to build it. So I had a look at it, upgraded it, basically rebuilt it from scratch using the latest versions, and I'm still developing it at the moment. I've actually been sat outside today, tweaking it and polishing it as I'm going along. So it's still in development, it's working, and it's now on GitHub available. I'll give the link at the end of the show. It's still available to be enhanced, should we say. So technology-wise, we're using the OpenStack Ansible project, Nagios core for the monitoring, StackStorm's a bit, there's all the clever stuff, and then building it using Vagrant and VirtualBox on the laptop. So they're the key technologies I'm using. So OpenStack Ansible, if you've not heard of it, it's a project in its own right. It's part of the big tent for OpenStack, and it's originally started by Rackspace, and it's the tooling we were using to deploy our cloud solutions internally. We'd used Puppet in the past, we'd used Chef in the past, then we developed this, and we thought it was pretty cool, so we open sourced it, and now it's a big project. Lots of people contributing it outside of Rackspace, but it's a tooling we use internally for deploying all our private clouds, and lots of companies use it as well for deploying their clouds. Scalable-wise, we've used it for deploying clouds with 1,000 nodes, and I've used it to deploy a single node. So it's very flexible, and it's a cool bit of kit. So if you're not familiar with it, definitely take a look at it. And I'm using the all-in-one solution here, the AIO build, for an all-in-one laptop solution. Nagios Core, pretty old-school monitoring project. I'm not saying it's best out there. We don't use it at Rackspace per se, but it's just something that was small, effective, easy to deploy, fully open source, and I could run in a separate VM on the laptop. Then StackStorm is the new kid on the block. This is the bit that is sort of gluing things together. So Nagios does the monitoring, AIO gives me my OpenStack solution, and StackStorm does the fixing when things go wrong. So StackStorm's got two versions, an open source version, obviously that's what I'm using, but it's also got a commercial version with extra features and tools. So again, take a look, it's quite new. I think it's still really in beta. It's still being developed, but they're welcoming suggestions and contributors, etc. So have a look at it, it's really quite cool. In a nutshell, what it does, it's basically a monitoring platform. It works in monitoring platforms, so it takes in the events from, in this case, Nagios. Those events get monitored, rules run against the events, and those rules are what dictates what happens. So if the rule decides we need to do something, then it initiates a trigger. That trigger triggers an action, which has an effect. So in this case, what I'm going to show later on is that I'm monitoring the system in Nagios. It's monitoring OpenStack services and processes. If I kill off a service, Nagios detects it. It's monitoring it, it reports it to StackStorm. I've then got rules running in StackStorm that say, if condition X happens and condition Y happens, after a certain amount of time, take this action. And what it's simply going to do is going to go back to the appropriate container within the all-in-one VM and restart the appropriate service. So it's a simple example of what you can do. We can actually do far more complicated things than that. We could plug into the actual APIs in OpenStack and do more complex things. I'm still building it. It's current state is where it's fixing all the different processes and services. But StackStorm is a bit that does the wizardry at the end. VirtualBox. What can I say about VirtualBox? It's a simple hypervisor that you can run on your laptop. Runs on all the standard platforms. It's a great little tool for developing and test environments, etc. And then Vagrant is the sort of bit of magic that you can use with VirtualBox to bring things online and make things build for yourself. So, for example, in this environment, to actually deploy what I've built here, all you need to do is clone the Git repo and do Vagrant up. That's it. 2 commands, the whole system will build for you, all the configuration is done for you, it's all driven by Ansible, Vagrant, VirtualBox, etc. So I'm using the tools available to me to make my life as easy as possible, that automated build. I don't like doing things twice. So what we're aiming to achieve is we've got a fully configured running OpenStack solution on the laptop. We've got the Nagios monitoring server, monitoring all the different containers within that build of OpenStack. And then we've got the StackStorm server, which is communicated with the Nagios server, ready to actually do things if Nagios detects a problem. So that's what we've got running live on the laptop at the moment. So how do I go about building this? So building it manually is quite easy, but getting the Vagrant integration to work proved a little bit more challenging. And some of the problems there, I wanted it to be fully automated so that I can just do Vagrant up and things come online. Now, the all-in-one configuration, by design, is all-in-one in a single VM, and it's not really designed for external connectivity. So I needed Nagios to be able to connect into those VMs and monitor it, and then StackStorm connect into it and actually do things. So I had to access those containers, and the default configuration didn't really work. One of the problems with Vagrant is it gives you a default interface on your VM when it creates a VM for you. You can't change that, it's by design. And all-in-one configuration is designed to use ETH0 for most of its configuration. So the two conflicted, because Vagrant uses that as a NAT interface, and each one gets the same IP address on every VM, which is rather unfortunate. So I had to work around that issue. To do this, I had to configure basically the all-in-one VM to remap the traffic to different interfaces on the VM. Now that sounds slightly complex, but actually the all-in-one VM is configured for that type of configuration. So you can easily pipe in extra configurations or change default config files and make changes as you need them. So I worked out how to do that. I then hit a problem where the all-in-one's looking for a particular size of disk, and Vagrant images, which I was using, were always smaller than the minimum disk size. So I had to work around that, and I did so by adding a second disk and then telling the all-in-one to use a second disk for its images, which was larger than 60 gig. Now, the all-in-one VM is running containers, and all the containers on that VM have a management network IP schema. Now, those IPs are randomly allocated every time you rebuild the environment. Now, I needed my Nagios VM and my StackStorm VM to have an IP from that IP range so it could talk to them. But I wanted to ensure I didn't get any conflicts. So again, had to modify the config within the all-in-one to say, this IP range is reserved, don't allocate it to a container, so we know the VMs can talk to it. Again, it's a design feature within the all-in-one configuration, so you can modify things. Likewise, because of that default ETH0 issue, there's a load balancer that runs within the all-in-one containers, because you can actually run 3 instances of the Galera cluster to simulate a configuration. So the load balancer needs reconfiguring again to allow for the interface changes. So all of this really comes about from wanting to use Vagrant to get the environment up and running, gave me a lot of headaches to get actually things working. And finally, the all-in-one solution is designed to run Ansible locally on that VM. So I needed to get Ansible on my laptop to trigger Ansible on the all-in-one VM. Now, as regards to Vagrant configuration, it's all basically configured in a single file called Vagrant file. And I've used a slightly different configuration you may have seen in the past because we do a lot of vagrant file stuff where I have multiple VMs where I might type in a device, say I want 5 of those. So I've got lots of loops in there, and this is using that same construct. So at the top of the vagrant file, those are basically the IP addresses, the 4th octet of each VM. So if you want to change the IP schemas, you change those 100, 101, 102 IP ranges, and obviously change the appropriate Ansible configuration as well. As regards the image, I'm just downloading an image from the internet. Because it's always nice and safe. But I've not built my own, there's no point. The ones are out there, I'm using that one. And I'm also using the cloned feature where I use link clones to save disk space. So once you've got that image downloaded, it gets cached on your laptop, and I can rebuild this environment very, very quickly. Now in Vagrant, I've got a set of default configurations, and these just basically specify memory, CPU, etc. But you'll see I've made a few tweaks in here. So I've basically turned on link clones. I've enabled a group, the AIO-Nag ST2 group. It's just cosmetic within VirtualBox. It keeps all the VMs in one little grouping. And then I've set the defaults for like memory, CPU, etc. Set the power virtualization mode for KVM. It's best for Linux VMs. And I've changed the NIC type because I was having problems with some of the features. Now, that's the default configuration. But then for the actual AIO VM itself, there's a few weird tweaks on the networking layer. So I've had to add the second interface, or the third interface, should I say, because we get default one. But the second interface, which is ETH1, I need the IP configuration of that not to be configured by Vagrant. Because Vagrant will go into the VM and set the configuration for you, but I need the IP address to be mapped to a bridge later on, and the Ansible playbooks within the all-in-one set that up for you. So I basically wanted Vagrant to know that as the IP address, so I can use it in playbooks later on, but not to allocate the IP address. So that auto-config false basically means it creates the interface, but doesn't assign the IP address. Now that itself causes problems in some of the early playbooks, because I've got to connect to that VM. The IP address I've got doesn't actually work. So I have to use the Vagrant sort of backdoor to get into there. So, but that configuration there disables the auto-configuration of the IP. Add the second interface, which is actually used by the VMs running within the all-in-one system for the VXLAN mappings. So it actually goes nowhere, but it's just an interface on the VM to map traffic to. And then those defaults we had earlier obviously aren't suitable for the all-in-one, so I've increased things like memory, CPU count, added an extra interface, and enabled promiscuous mode on those interfaces so that the VMs can talk to each other and traffic can go across them. Then that workaround for the disk space, I've added a second virtual disk onto that VM and just got it to auto-configure by Vagrant. So I've now got a VM with 3 interfaces and a second virtual disk. For the StackStorm server, all I need to change from the configuration from the defaults is give it more memory, more CPU. And then Nagios server, the defaults are perfectly fine. 1 vCPU, 1 vCPU, 1 gig of RAM, etc. So the Vagrant file is actually quite simple. I can't show it on screen in one go. It's too big. But it's basically configuring the VMs, configuring the networking, additional storage, etc. And we've got the VMs online. And those VMs come online in about a minute. So they come up very, very quickly. Now, I'm using Ansible to drive all of this going forward. So Vagrant will basically create the base VMs from that image, and it will configure it for us. And then it's going to basically talk to Ansible and basically say, right, now you go do your magic. So that's why Vagrant does all the work for you. As it brings the VMs online, it starts to build a dynamic inventory for Ansible to then use to actually talk to the VMs. So I've got no host file. I'm lying, I have got a host file if you want to do things manually later on, but it's not used. Vagrant actually creates its own dynamic inventory file, and then Ansible talks to that. So the VMs come online, you basically do an initial basic update, install NTP, so I can ensure that the all-in-one VM is the NTP server, the other 2 servers act as clients, and to ensure the time's always in place. Vagrant should keep the time in sync, but one thing with the all-in-one VM is once you built it, never shut it down, because you'll break things. So I suspend the all-in-one VM and tend to shut down the other 2. And then the all-in-one time drifts slightly, and then the other 2 come back online, and I get problems with time sync. So I'll just basically install NTP to get around that. But once Vagrant's got it up, we do those basic roles, and then Ansible takes over, really, and starts to install all the different roles for the all-in-one, the Nagios server, and the StackStorm server. And when I say Ansible is now integrated with Vagrant, I mean, as of today it is. It wasn't yesterday. So I had it running manually earlier on, but today I thought it's a good idea to get this finished today. So I spent most of today doing that integration. So word of warning, if you clone this repo in the next half hour or so, there might be a bug or 2 in it because I've not fully tested that new integration. But in the next day or so, it'll be polished off and will be fully working. I believe it is, but I've not had time to fully test it from scratch. So StackStorm, we build the StackStorm server first, and that's because we need to take configuration from that server and apply it to the additional roles. So StackStorm server comes online, and I didn't want to reinvent the wheel here. There's a really good StackStorm playbook already out there that builds all the roles for me. So I've just taken that from the StackStorm community, built it into my own set of plays and run their roles, and they work really well. But I've then added some additional roles myself because I needed extra functionality and configuration on the system. Now, StackStorm has the concept of packs, and packs are available for different systems. For example, there's an Nagios pack, and that gives you lots of different rules and triggers and configuration that StackStorm can use to work with Nagios. However, it doesn't work. There's problems with the Nagios configuration as it is. I noticed they made some changes as about 2 or 3 days ago, so they may have fixed it, because I've been talking to the community about this. But it wasn't working, so I basically cherry-picked what I needed. So I built my own pack. I've called it Nagios, maybe slightly confusingly, but I've got a playbook that basically builds the folder structure on the Nagios server, which is effectively, the StackStorm server, which is effectively a pack. And then I've taken some of the files from the Nagios pack that do work, such as the Python handler there, made a few modifications to it, and then utilize that. So it's pretty straightforward. It's easy to look at the code to see what I've changed. Nothing great. I'm not a Python developer, so relatively straightforward. Now, one of the rules, or the key components of StackStorm is the rules concept. So this rule is what is listening to all the alerts coming in and then decides what to do. So this is the rule file that I actually developed. And you can see basically what's happening is it's linked to the Nagios pack. And all it's doing, it's going to look at the service state change trigger. So that Python file goes onto the Nagios server, and whenever it gets a state change alert from the system, it basically uses a webhook to fire the information over to StackStorm server and say, have had this service state change, have a look at it. So what we're looking for is 2 criteria. So when Nagios has an alert, it starts off as a soft alert. So it's configurable in Nagios. It's configured on this system for 3 consecutive alerts. So it will start off a soft alert, and then it goes to a hard alert. So I'm looking for a hard alert, so it's had 3 failures, and also in a critical state. So pretty simple sort of pattern matching there. When that happens, it's going to basically say, right, take an action. And in this case, use the default built-in StackStorm action that is a Linux service action to basically say, connect to the Linux server that's had the problem and do something. So in this case, I'm basically taking the host address from that information sent in from the Python file. That's one of the changes I had to make because that wasn't in by default. Take the host address, take the actual service name, and basically say, go to that host and restart that service. And that host address will be the IP address of the container within the all-in-one VM, because it's all containerized. And basically, restart the service. So a really simple example of things you can do. Obviously, you can do far more complex things with StackStorm. I'm just scratching the surface here. This is a StackStorm UI. So it's just showing here that we've got the actual rules view, and it's showing there that Nagios rule and the sort of the criteria trigger state equals critical and trigger state type equals hard. And then there's a few more configurations below, do X, Y, Z. But that's what basically that rule looks like in the UI. So as well as that StackStorm pack, I also had to get a way for the StackStorm server to communicate with the different containers. So by default, it uses SSH, and it has a Stanley user. So basically, the reason I bring StackStorm up first is that I go into the StackStorm server, extract the public key for the Stanley user, which is configured by Ansible randomly when it's created, and then I use that to push it into every container within the all-in-one VM, so we've got the authentication in place. Nothing too complex. So we've now got the StackStorm server online. We now need to build the all-in-one VM using the Ansible, OpenStack Ansible project. Now, the manual way of doing it is quite simple. You can run through those sort of steps, but its manual takes far too long. So rather than do that, I wanted to actually fully automate it and make my life nice and easy. So basically, I use Vagrant to build the VM, and then I use Ansible to configure things going forward. Now, in order to configure the Ansible all-in-one for how I needed it, bear in mind all those network changes because of Vagrant, etc., I had to pipe in various information. So I'm using playbooks on my laptop using Ansible to reconfigure playbooks on the all-in-one configuration. So it's Ansible driving Ansible effectively. I've got ahead of myself there. So once we've done that reconfiguration, we then fire off Ansible locally. So we get Ansible to reconfigure Ansible on the all-in-one and then fire it to make it do what it needs to do. Now this bit takes about 2 hours. So this is where you go and put the kettle on, because the all-in-one build is installing OpenStack. You know that's no mean feat, and it takes a bit of time depending on the speed of your laptop or host you're running on. But if you're allowed 2 hours, come back and it should all be built. So once the actual all-in-one's done the basic OpenStack install, and I've got OpenStack working, it then carries on, and it starts to do alternate configurations. So first of all, I need to update Ansible, because I'm using playbooks later on that I've written based on Ansible 2.1, sorry. So I'm using some of the features available in the latest version of Ansible. And the all-in-one Ansible version pins it to 1.9. So I update that, and then I run additional roles to put the Nagios monitoring roles in there, put the StackStorm webhooks in, and other configurations. Basically ensure that everything can talk to each other. They're pretty straightforward. Look at the playbooks, you'll see what's going on. I've used a lot of tagging and descriptions in the play to try and describe how things work for my own benefit and anyone else wanting to use it. So at that point, we've got an all-in-one built, we've got the containers running, and they've had the configuration enabled for monitoring StackStorm keys, etc. So the next issue was to start building Nagios. So I thought, hey, how hard can it be? There's documentation on the website there. There's lots of different playbooks around that do it for you, mainly around Nagios version 3. And I thought, hey, why not use the latest and greatest version 4? About 2 months later, I finally got it working. It wasn't that easy for some reason, but I eventually found this website here, which was a really good article on how to do it manually. So I literally followed the steps in there with some modifications, and then basically wrote my own playbook from scratch to do what needed to be done. So this is the bit that was the next biggest challenge, having got the communication with the Vagrant configurations working. So, excuse me. Basically, the Nagios role, it stores lots of dependencies that need to be put on there. We update Apache. It grabs the tarballs and the binaries and then runs make and configure and all those things. So when I write playbooks for Ansible, I like to make it fully what I call Ansibleized, and I don't use any command or shell components. However, for this playbook, I had to fall back to the command line features for things like configure and other elements that Nagios needs. It's not what I would call 100% Ansibleized, but it is idempotent, so you can run it again and again and again, and it won't break or fix or change anything that's been configured previously. This whole play can be rerun as many times as you like. One of the things that we're doing there, as well as building Nagios, we're installing the optional plugins and the remote plugin executor, which is the bit that's actually communicating to the oh, excuse me, I've forgotten what they're called, containers, on the all-in-one VM. So you can use SNMP monitoring, but I'm using the NRPE option instead. I think it's a better methodology. So it goes through and it then does all the configuration and gets all the configuration files. So as part of the actual repo, I've written the configuration files that Nagios needs to talk to each of the containers. And that's actually the bit that takes the time now. I've probably only configured 1/3 of all the services that OpenStack needs to be monitored. So it's still in progress, and it takes probably about 5 minutes per container to configure what you need. So that configuration file basically goes into that folder called servers, which is on the Nagios server, and then it reads those config files, and we link it to a command file that basically says, you're going to run this command for this particular container. So every container that I want to monitor, I create a config file, put in that config file what's required to be monitored, and then that's the link between Nagios and the actual monitoring itself. Now, to do that, I've created a template for the AAO containers. I could have just used a Linux server, which this is a clone of, but it's just a way to, if you've got a configuration option that you use in every container, you can just put it in a template and then sort of have a hierarchy structure in place. So that's like the default configs for the host configuration. And then we've got some default configurations for the service configuration. So you can see in there we've got the event handler, st2 Nagios. That's that Python file that we use to actually do the event handler notifications. It gets installed on the Nagios server, and it triggers the information over to StackStorm. And then just various configurations. You'll notice I've got quite a short check interval of 0.25 of a minute, because that's good for demos. Normally you'd have like maybe 1 or 3 minutes, but I do it quite quickly so that when I break it, within about 1.5 minutes, it's fixed again. Because it's nothing more exciting than watching a 3-minute demo with not a lot happening. As regards the config file itself, so here's an example for the Keystone container. Now you'll notice I've got the IP address in there, and you'll have remembered that I mentioned earlier, that's randomly allocated for every time you build the system. So what actually happens when the all-in-one VM build runs, we actually take these config files from the host machine, copy them to the all-in-one VM, then use a dynamic inventory on the Ansible all-in-one to connect to every container, read the Ansible facts, update these config files, and then push them back to the host machine so they're ready to be deployed onto the Nagios server. So having run this, you'll notice that if you then do a git sync, you'll see that all those config files have changed on your version compared to the online version. It's not a problem. Those IPs get changed for your configuration, and then you're good to go. So that was also one of the challenges I had to actually make that information get passed from one machine to the other. Basically, then we define a service. So here's an example service. Nagios templates have quite a few services in there by default, things like ping, SSH, load, current user, zombie processes, etc. So I've got all those in there as the defaults. But we've also then got the sort of OpenStack specific ones. So as regards Keystone, really the key service is Apache, because that's running the authentication connection. You come in on HTTPS. So if Apache falls over, effectively Keystone falls over. So I'm monitoring that, and if we get a problem, we can use the command check Apache 2, and that's what tells StackStorm what to do. So that's what we've got to. Now we pray to the lab demo God that it's going to work, which of course it will. So the idea is we've got a fully functioning, we've got a functioning system. So we've got, where's it gone? Yep, there's my OpenStack installation. It's a working system. I can log in, I can authenticate to show it is working. Now we've got Nagios monitoring it, and you see I've got a selection of containers being monitored in different services, and all's green, which is good. So if I go in and say break the Horizon one, or Keystone, let's do the Keystone one. So we see Keystone's all good. Now to break things, I don't know how well you can see this with the resolution. All I'm going to do is connect to the container and break the service. So Keystone is now I could use LXC attached from within the all-in-one VM, or because of the way I've got the keys being distributed, I can actually connect directly to those containers. He says confidently. There we go. So let's see what's happened to OpenStack. It's broken. Oh no. He says it should be broken. Let me log out, log in again. Why is it not broken? It is stopped. You normally get a big SQL error, and it looks. Right, well, I can't log in, so there's the break. And we see now we've got an error. So if we go to services, we're already at 2 of 3, so that's 2 soft errors. As soon as we get 3 of 3, it'll be fixed. So I've got to be quite quick because I've got a short configuration. So if we look at the history now in StackStorm server, now this does seem to take its time to refresh on the laptop because I'm running Keynote, I'm running OpenStack, I'm running StackStorm, Nagios, and it's struggling. But while that's refreshing, which it will in a second, let's go back and log in again. And let's type the right password. There you go, live demos, never do them. Right. Okay. Oh, thank you. Oh, and here we go. Linux service been restarted. Service Apache 2 start. And if we go back to that, it's back running again. So I could do the same with any service that's monitored, where I could pick one at random, and it'll kill it off. There you go, it's gone. Go back to the main view, and we're all green again. So the concept here, basic example, I'm just monitoring the processes on the containers, and if the process goes down, I restart the appropriate service, things come back online. I'm going to expand this. So, for example, in my demo environments, I often have pre-configured projects and VMs running and configuration. So I'm going to monitor that as well. And then if a VM goes offline, I'll actually get this to trigger my my Ansible playbooks that do all the configuration for me and get the environment back to where it needs to be. So my VMs within OpenStack will also be monitored. Nagios is monitoring, StackStorm does the configuration. That's a really simple example. One of the powers of StackStorm is that you can actually run much more complex sort of rules and say, if this happens, do this, then this, then this. So if you've got dependencies and one thing breaks, you can say, right, if that happens, you need to fix this, then that in a particular order. That's basically it. Any questions?
Okay.
Oh, sorry, I forgot to mention, apologies, before questions. That's the URL for the GitHub repo where you can actually connect to it and download it. So it has been modified today, should still work, but I'll test it myself when I get home tomorrow to make sure it's all good and fix whatever I've broken today. And the really complex way of, there you go, all you need to do is clone, there's the full URL, clone it, oh God, go into that folder and run Vagrant up. And Vagrant will do all the magic for you. It'll fire all the Ansible playbooks, do all the configuration, give it 2.5 hours to actually do all this magic, and you come back and you'll end up with those 3 UIs all up and running. So have a look at the all-in-one website if you're not familiar with it, Ansible, OpenStack Ansible all-in-one, and it tells you how you can log in and get the password from the actual configuration that's been generated. Now, any questions?
Okay, thank you. So thank you for a great presentation. We've seen the failure, the recovery, and let's see if there are any questions about either of them.
Good, bye.
Okay, that was very quick. Okay, then I'll start with a question. So is that something that you widely use at Rackspace, or that's just your pet project?
No, it's purely my pet project. We have our own monitoring services at Rackspace, which I can't use in this type of environment, so I wanted something self-contained, so that when I know I'm going to do a demo, things are functioning. And again, it's also for my own learning on how to do this sort of thing.
Okay, so then a follow-up question to that, do you think there would be any scalability considerations? So if I have like a huge data center, can I use this amazing tool?
I'd say possibly not. StackStorm, yes. Nagios is probably not the best solution for very large scale.
Okay, so I'll not use it. Not that I have a data center. Any more questions? No, I think it's everything is so clear that perhaps you'll get questions in the break. Okay, then we meet again at 4 o'clock for the last session. Thank you.
Thank you.